This is a small video on multi-stage amplifiers. Actually, this is an introduction to the topic multi-stage amplifiers. What is a multi-stage amplifier? A multi-stage amplifier is an amplifier with more than one stage in the amplification process. This means you have to use more than one transistor. Here, you can see a general representation of a multi-stage amplifier, where this is the first amplifier, which is connected to the second amplifier, then the third amplifier, and so on. We have a large number of amplifiers. Why do we have a multi-stage amplifier? What is the need of a multi-stage amplifier? Usually, the voltage gain or power gain obtained from a single stage amplifier is limited. This is not sufficient for some practical purposes. So we use more than one amplifier in a chain so as to obtain the desired voltage gain or power gain. Here, the output of the first stage will be fed to the input of the second stage, and the output of stage 2 will be given to the input of the third stage, and so on. The multi-stage amplifiers are broadly categorized into two types. One, cascade amplifiers, and two, cascode amplifiers. So what is the difference? This is a cascade amplifier. In a cascade amplifier, all the transistors in all the stages are arranged in common emitter configuration, as shown in the figure. See, this is the first transistor and the first stage of the multi-stage amplifier, which is common emitter in configuration. And the second stage, we have another transistor, which is also common emitter in configuration. So, irrespective of the number of transistors or the number of stages in the multi-stage amplifier, all the transistors will be common emitter configuration in the case of a cascade amplifier. Then the second type of multi-stage amplifiers, it's called cascode amplifier. This is a cascode amplifier. In a cascode amplifier, the first stage will be a common emitter configuration. The second stage may be either a common collector configuration or a common base configuration. That's the difference between a cascade amplifier, where all the stages are in common emitter configuration, and a cascode amplifier, where the initial stage will be a common emitter configuration and the latter stages will be all in other configurations other than common emitter configuration. Now we need to think about the gain of multi-stage amplifiers. In fact, the multi-stage amplifiers are designed so as to improve the gain of amplifying system. So we need to study about the gain of multi-stage amplifier. In a multi-stage amplifier, each stage has its own amplification. The total amplification is the product of the individual amplifications. This is true in the case of voltage amplification, current amplification. Let's assume that we have three stages in the multi-stage amplifier, and the voltage gains are, say, AV1, AV2, and AV3. Now the total amplification is AV equal to AV1 into AV2 into AV3. This is in fact AV, not AV1. It's a total amplification. Likewise, if the current gains respectively are AI1, AI2, and AI3, then the total current amplification will be AI equal to AI1 into AI2 into AI3. So we have the current gain and the voltage gain. Then the total power gain will be the product of the current gain and the voltage gain, which is AP equal to AV into AI. It is customary to express the gain of amplifiers in decibels in honor of Alexander Graham Bell. Here, the gain is expressed in logarithm to the base of 10. See, what is the voltage gain? The voltage gain, the total voltage gain is the product of the first voltage gain into the second voltage gain in the third voltage gain if it is a three-stage amplifier, as we have discussed earlier. Then taking the logarithms, taking logarithm of these voltage gains, that is 20 log to the base 10 AV1 plus 20 log to the base 10 AV2 plus 20 log to the base 10 AV3. When you take the logarithm, you're adding them together instead of multiplying the gains. And together we get it as 20 log to the base 10 AV. Likewise, we can calculate current gain. And it is given by GI equal to GI1 into GI2 into GI3, which is 20 log to the base 10 AI1, where AI1 is the current gain of the first stage, plus 20 log to the base 10 AI2, plus 20 log to the base 10 AI3. Together, it forms 20 log to the base 10 AI. Then what remains is the power gain. The power gain is given by Gp equal to 10 log to the base 10 AP, where AP is the power gain, which is given by the earlier equation AP equal to AV into AI. In the next classes, we'll think in more detail about the multi-stage amplifiers and its working.